So in this video we'll show just a brief introduction to RStudio. So when you open up your RStudio software, you'll find a screen that looks like this. So on the upper left panel here we have where you would write your script. On the bottom left we have your console, which is where you would type your individual commands and where you will see your output as well. Then your global environment, and on this tab, history, you can look at the history of all your commands. And then on the bottom right here, we have our files. So when you have a folder, once you install your RStudio, you'll select a directory and folder where you would store all the R files and where you can place your data files so you can call them into your R software. Also in this tab we have plots, where you will see your plots. If you plot some diagram, you would see it here, and then the available and installed packages that you have. Also a help tab and a viewer tab. Okay, so to get started, the first thing we should go through is how to upload data, right? And that's important. So you can upload data in various ways, right? So for example, we just go to File and import a data set, and you can import from a CSV file, from Excel, from SPSS, from SAS, and from Stata. Right, for this example, I'll just upload a file from Excel. So it's in an Excel sheet, and we can browse, and you will see all the available stuff. So I'll just click on student data, which is just a small data set I've done for this purpose. Right, and you can preview it here. You'll see the data, and then so also, if this is not clicked first row as names, then it will treat the first row as if it were numbers, right? So here we want to click first row as names because that's how we're defining our variables. So import, and you'll see in your global environment the student data file that has been uploaded. And here you'll see the data itself, 8 observations of GPA and ACT scores. Okay? So with this data we can now start working with simple commands. So I'll start with maybe just running a simple regression. And this is an OLS regression, right? Ordinary least squares. And in this here, we'll first name the regression, whatever you want to call it, so you can call it back. I'll call it reg1 for this example. And that reg1 equals, you can either use the equal sign or the less than and a dash, so either or. And the command for the regression is LM, which stands for linear model. We'll open a parentheses, and the first variable is going to be your dependent variable. So let's say that our dependent variable is GPA. After you define your dependent variable, then you will enter a tilde and your independent variables. Okay, so for this example, we're going to say ACT is our independent variable, then comma, and now we're going to tell R which data set to use. Right? And student data is a data frame, and now we just type enter, and you'll see that in your global environment you have reg1 now. So you can summarize reg1 to view the output by typing summary and on the parentheses the regression name, whatever you saved it as, right? And here we'll see the output. So we have our coefficient, the intercept, and the ACT coefficient, and the respective standard errors and t-stats and the p-values. Okay. Also down here you'll see the standard errors for the residuals and the R squared and the adjusted R squared. Okay. So now after you've run a regression, maybe you want to, I don't know, save the residuals from this regression, right? So in order to do that, you will name whatever you want to name the vector of residuals. In our example here, I'll say u hat, and we're going to call the residuals from the regression one, reg1, right? And that's how we save them. Now this command is saving a vector of residual values, okay? By typing enter, we automatically see this in the global environment, a vector 1 by 8 of the residuals, okay? You can also save the fitted y values, right? And I can create a variable called y hat, which are going to be the fitted values from the regression one, yeah? And here we have a vector of fitted values, okay? You can also perform standard operations to these vectors. So for example, I might want the residual squared, right? And for that, I would just name it residual u hat squared, maybe. And just say that that's going to equal u hat, which I saved before, squared. And that creates a vector of residual squared. Right? Now, so one thing you can do as well is maybe if you are interested in looking at the first few observations of any of these vectors, you can type head and the variable name. So let's say u hat, you want to see the first 6 observations of u hat. We would type that, and here you have them. Yeah? And you can do that for any of these variables. One thing, when you're looking at what you've downloaded here, this is a data frame. So it's like a matrix, right? And this particular frame has 8 observations and 2 variables. So think about it as a matrix of 8 rows and 2 columns. But you might want to extract one of the variables here in this matrix, right? And we can do this by the command, so we'll say student data, so what we'll do is we'll name it something. So let's say we want to extract the ACT scores. Right? So we're going to create this variable called ACT, and that's going to be drawn from student data, from the data frame, which is student data. And then we'll enter the $, followed by that column you want to extract. Okay? So what you're saying here is, let's create a variable called ACT, which is going to equal to the student frame, the student data frame, the column titled ACT. And here we've just generated a variable of that particular column. Also, you can get summary statistics for the new variable, right? So you type in summary ACT, and you can look at the summary stats for this. You can get the mean of this ACT variable individually, or you can get the, I don't know, standard deviation, the variance, whatever you want. Okay? Covariances, stuff like that. Now, another thing that you might want to do is add a column of variables. And for that, we'll use the command so we're saying here to the student data, let's add male, and this is just a dummy variable, 1 for male and 0 for female. So we can do this, and it's going to be 8 observations that we're adding, right? Because we have 8 observations, so it's going to be 8 entries. And we run this. Now, if you look back here at the data frame, student data, we have 8 observations and now 3 variables because we've added a column that defines